Hello everyone, greetings from security first and AI powered networking world of HP Aruba. I am Ananya Talwar, technical marketing engineer with CX switching team, and I welcome you all in AOS-CX 10.14 release update. Today in this session, we are going to focus on one of the most critical part of enterprise networks and look into some of the new features offered by AOS-CX to support the effort of sustainability. So let's get started. So briefly, at a broader level, sustainability effort can be considered as a three-step process, with monitoring being the first, analyzing being the second, and finally taking the action. Monitoring means to retrieve the relevant information from the device and then further analyzing the obtained metrics and information to take necessary action against it. You can consider monitoring as one of the major prerequisites to perform any further steps on this effort. So the power monitoring in network infrastructure is directly linked to sustainability efforts. By carefully tracking and managing the power consumption of network devices, organizations can significantly reduce their environmental impact and contribute to broader sustainability goals. So there are few things that as a network admin or as a user you can do while you start the power monitoring for your efforts. First, the power monitoring tools allow organizations to track the energy consumption of their network devices in real time. By analyzing this data, network administrators can identify devices that consume more power than necessary. Another point is about optimizing the power usage. So with the detailed power consumption insights, administrators can optimize the network setup, such as turning off unused ports, adjusting power settings, and many more. Another part is the impact on carbon footprint is directly related to sustainability. So the reducing of power consumption directly lowers the organization's carbon footprint, which is really crucial to move on the road of sustainability journey. Talking specifically to the CX switch, users can explore new methods of power savings such as taking power devices to automatically power down in non-operational hours. We'll talk about more of this in upcoming slides. But now circling back to our initial thing, which is the monitoring. So as you have seen, you have a lot of actions to perform, which cannot be done unless and until we have the capability to monitor these criterias. So for the CX switches specifically, as a user, you may want to monitor the total power consumed by the switch, which includes the system power itself needed for the system crucial functions, the PSU power lost, and the PoE power drawn from the switch. The PSU power loss is actually the difference between the values of power supplied to PSU and the power supplied by the PSU to the switch. To support this, with 10.14 release, AOS-CX has introduced two new capabilities for the users. The first one is reporting power input of PSUs for the switch. And next one is reporting average and instantaneous PoE power drawn per chassis or LC or VSF system. Let's look into them one by one. The first one is reporting power input of PSUs of switches. Now, as many of you might be already aware that CX switches are intended to operate with specific PSUs that draws power from the wall sockets and distributes it to the switch component to perform different networking tasks. Now, these PSUs What HP Aruba offers are 80 plus certified with platinum and gold ratings typically. So 80 plus is actually a certification for the power supplies and a significant indicator of a power supply's energy efficiency. The platinum and gold ratings signifies or ensures the minimal power loss with PSU efficiency being beyond 87%. Efficiency is actually calculated as the value of P out divided by the value of P input into 100. P out is actually how much power being available for the system to perform the necessary tasks, while the P input values is what the system is consuming from the wall socket itself. There are two resistors on PSU that are responsible to capture these P input and P output values, which are further then stored to the system memory. As I was mentioning above, P input signifies the power supplied from wall socket to the PSU, while P out is the power supplied to switch modules by the PSU itself. So for power monitoring and power consumption calculations, if you think at an in-depth level, P input values is a great metric to understand the total power being consumed by the switch. So now before 10-14,000, CX switches were capable of reporting power consumption. Using this CLI command, you were able to see the power consumption. What you are seeing right here is the output is the P out values, not the P in values. So making it more clear, it's the value that is being supplied to the switch by PSU. So this is the instantaneous value, the instantaneous power that's coming in from the PSU, and this is the average one. Now with the 10-14,000, we have made a segregation here where there are two outputs to display with this same command. First is the power usage and next one is the power output. Power usage is the value that is telling you the power supplied to the PSU, while PSU output is still the power supplied by the PSU to the switch. So comparing the previous and the later ones, these values are now the part of PSU output display. And this power usage matrix is introduced as the new output in 10-14,000. So what is that makes this monitoring or this value really important to be displayed or to be known as a user or a network admin? What does it really brings to the table? Let's look at understand a use case example. Now, here I have taken an example for a large network deployment environment. Consider your switch count is approximately 1,000. Now, I'm here assuming that all of your switches are having same average power consumption. So before 10-14,000, consider you are having the power consumption output as this, and you're using this average value to calculate your power consumption for your network deployment, which means you are using 108 into 1,000 switches, which is giving you 108 kilowatt power as a power consumption. Now let's jump to 10-14,000. Now here you have another metric, that's the power usage. Here the power usage value is average value is 117. Once again, you do the similar thing and you calculate the total power consumption for your deployment, which comes out to be 117.67 kilowatt. Now, for exactly this instant, if you try to differentiate both these values, so you will find a big difference, which is actually notable and was missing from the power consumption calculations which you were doing earlier than 10-14,000. So this is where this metric is a better option to help you out to plan your resources and monitor your switches for your total power consumption. So talking about the product support, Here is a list of products that actually are able or capable of displaying this metric. It should be known that there are certain SKUs or switch families that does not support power consumption command, while there are other SKUs that support power consumption command but are not capable of displaying power input values due to technical constraints. And these examples include 6300F models, 6200F models, or 6300L models. Let us dive deep into details of this feature. So once again, with 10.14,000 update, power consumption output is supposed to display first the power usage, which is the power supplied to the PSU from the wall socket. And in the above slides, we have seen it as P input, while the other one is PSU output, which is the power supplied by PSU to the switch modules, which we have seen as P out. Now for each of the above fields, further two metrics are displayed. First is average and the other is instant. So for power usage also there are two values, instant and average, while for PSC output as well there are two values, instant and average. So instant is the value of instantaneous power that is being consumed by the switch, which includes the system power and the PoE power drawn. Average value of switch power is the power consumption which is calculated over a average period which is defined by the user. Now the power consumption average period can be user defined by this command, which is power consumption average period. Now user can configure average time right from 1 minute, which is 60 seconds, to 60 minutes, which is 3600 seconds, with 10 minutes or 600 seconds as the default value. Now platforms where the power input values is not supported to be displayed, power consumed will be displayed as power usage and PSU output power will be displayed as non-available. So in the VSF stack, if a member does not support power consumption command, CLI will display not available under each field of that member. Let's jump to the configuration part of this feature. So just to give you a brief idea, when you do a power and check the help for this command, you'll be able to see the option of power consumption average period. This allows you to configure your average period of time over which your average power consumption is being calculated. As I was mentioning that this can go right from 60 seconds to 3600 seconds, and if you will try to go out of this interval or try to insert any values that is out of this interval, the invalid input is going to be printed on the CLI. It should be noted that the average time period, whatever we are configuring right now, is common for all power consumptions calculations or wherever power average is being calculated. So now we can see or we can use the show commands to check these power consumption values. Again, here I have tried to show how the CLI can help you out to know this command. So if you do the show environment power, it will be listing three further power commands. So for a standalone switch, you can do a show environment power consumption and it will list your power usage and power output values with the switch description itself. For the VSF stack, again, when you will type this command, it will list all the members with each members how much power is being consumed. And again, both the metrics, power usage and power output. Another thing that it will add here is the total power consumption of the whole system, which means the total VSF stack. The power consumption is further can be again customized with further filters, such as you can type show environment power consumption detail, which will show the module power consumption information. Member is in case of VSF stack, you can check out the power consumption for each member. And further, we have power over Ethernet, which here we are going to talk about in the next part of this session. So the switch environment power consumption detail will list out the chassis total along with both of these metrics. In the VSF stack, it will allow you to check out the power consumption of each member with member limit being from 1 to 10. So to check out for each member, you just have to type show environment power consumption member and the member number for which you want to check it. Here is an example for a SKU which is not supporting the P in values to be printed. So for this, the command is same, but when you will try to display these values, the PSU output will be mentioned as not available, and this value, whatever we were supposed to see here, is printed as the power usage directly. Here is a diagnostic show of power supply where you can see again these two metrics are displaying the instantaneous values as power instant out and the power instant in. This command or these details can also be fetched via REST itself. So what you have to do is you have to reach to the switch UI and open the 10.14 API. Next, after logging in, you have to scroll down or navigate to subsystem, where you have to choose the subsystem name option with subsystem type customization. Now, after clicking try it out, you have to choose subsystem type as chassis. Under subsystem name, you have to type the subsystem name as the integer, which means you have to type 1 in case of a standalone switch and the member number between 1 to 10 in case of VSF stack. Now, if you want to specifically check out the power consumed average, you can go to the attributes and select only average, which will just exclusively display the average power consumption value. Here, I haven't chosen the specific attribute, rather I have printed all the outputs. So for me, it is showing the power consumed, which is the instantaneous power consumed value, the power consumed average, which is the average value calculated over this average period, which is 600 seconds in this case. Now remember that these values are actually the power usage value and not the PSC output values. So these values are actually giving out the total power consumed via switches right now. These details can also be fetched via SNMP MIB, where this Aruba wired chassis MIB actually support the Aruba wired power statistics, where you can go and check that power states values is mentioned here, which reflects the average value, not the instantaneous, but the average value of power usage. Again, not the PSU output. So this is the total power consumption being reflected here. So let us now look at the second feature that I was mentioning earlier that will support your effort to sustainability. So this is about reporting average instantaneous PoE power drawn per chassis or LC or VSF. So let's look into the details of this feature. So before 10-14,000, PoE power drawn for each interface can be checked via CLI using this command, which is show power over Ethernet. So this command lists out the Instantaneous. Now, this is where I just want to press a little bit that this is the instantaneous value of PoE power that is being drawn by each interface of the switch. Now, you can obviously customize it further to get the specified output, such as for multiple interfaces or probably for the range of interfaces. But using this command and using a brief, you'll be able to see how much PoE power is being drawn at that instant and what's the value for each of those interface. Now here is what briefly was available before 10 14,000. So the PoE power drawn by each interface, which you can see right here, it is available and it can be seen. The next part is instantaneous value of PoE power. So this value, whatever you see here, is the instantaneous value. Now there was an additional requirement that made more sense or that will help you out to understand these details better. And what were those? Actually, it was along with the interface specified PoE values, you might also want to see the system level PoE power consumption and average value of PoE power consumption over a specified time period. So following these guidelines with 10 14,000 release, a feature is introduced which is average instantaneous PoE power consumption, which is a feature which is used to collect and report instantaneous PoE power consumed for each port. This is for all the levels of your system, like for each port, for subsystem. Now by subsystem, I mean for each member of VSF stack, for a specified LC or a chassis switch, or per system. Per system means the whole VSF stack, standalone switch, or the chassis switch itself. So this command is going to display all those details for all different levels you have in your network design. Here is a list of platforms that support this command currently. So for the SKUs that support PoE, this command is available and can be used. So what is the real requirement of this feature? What's the use case? How are you going to use for your network deployment? Now, understanding PoE power drawn for each subsystem or switch port is really important to plan and explore power saving options that may underline there to help you out to achieve your sustainable goals. Now, this empowers users to monitor PoE power drawn by their power devices, which in turn helps to plan out PoE power distribution in low usage hours. Now, let's take an example. Consider that most of the buildings in current world do not operate 24 hours a day and usually are closed at night. So, considering this fact, it makes it perfect to power down the power devices which are not in use, especially during the time where the buildings are non-operable. So the PoE devices can be categorized and tagged for periodic power down to achieve the efficient power savings. So in order to achieve your power saving goals, you might want to tag your power devices with different categories so that periodically when they are non-operable or expected to not operate in a certain period of time, they can be powered down and that energy can be saved. Now, the factors that might be considered for tagging the device is the criticality of that power device. By criticality, I mean that how critical is that device for the business itself, such as a security camera that is being there for your gates or probably a biometric scanner are the critical devices which might not be shut down at any point instant of 24 hours. But on the other case, your hallway lights, which are not being used at night, can be powered down. So this is what the criticality of device really mean. Another thing is the peak usage hours. So consider this fact when the all the employees are there in the office, which starts early morning and ends in the evening, that morning to evening time is actually the peak usage hour of most of your hallway lights or the PCs that are there for each cubicle. So now you know that for most of these peak hours, this much energy is being drawn for these devices. Another option that you have for the tagging of the devices is amount of energy savings that a device can bring to you. For instance, a specific device is drawing certain power, but if you are trying to bring it down, the savings are not that much efficient so that it can make a notable change. And hence you might not want to consider it as a power saving option. Whereas there is a device that is drawing a power and bringing it down or powering it down for a certain period of time really brings a notable change. So you might want to consider it. Another option that you have is the location of the power device. As I was mentioning in earlier examples, some of the devices might be in a cubicle or in a cabin, in an office cabin, or in the hallway and similar locations. So for instance, if there is no one in the cubicle or in the cabins itself at night time, you won't need those devices to be turned on or to be up. So that location of that power devices really help you to identify whether it needs to be down or how can I tag it for my efficient power saving options. So this was one of the examples how clearly monitoring these power saving options can help you out to make a better decision. So all this analysis, what I have mentioned earlier, requires a thorough monitoring of your PoE power consumption at the each level of your network deployment. Hence, this feature is going to be a plus one or an add-on in a brief view to reach your sustainable goal or the power saving goals. So let's look in the details of this feature. The average time that we are talking about in this feature is user configurable. Once again, it's similar to the previous feature we saw, which is configurable from 60 seconds to 3600 seconds. Now the default average time period is 10 minutes, which is equal to 600 seconds. The average time period configured is common to the system power consumed, which we saw in the last feature, the PoE power consumed per subsystem or the PoE power consumed per port. So for all the levels or all the similar features, the average time period which you configure remains same. So the PoE power consumed is actually collected as the samples in every 5 seconds and average is calculated over the period whatever you have specified, which is the power consumed average period. So PoE power average is updated per subsystem level, as I was mentioning, and per port based on PoE capability of the switch or the port. So the PoE power samples are collected in a buffer of size 3600 seconds. So as you see, this is the limit for your buffer in seconds. So for 3600 seconds, that buffer can hold the samples, which is taking samples in every 5 seconds. So when the full buffer size is reached, newer samples will become the part of the average and the old samples are dropped. Now, to calculate the instantaneous PoE power average, this is how it is calculated. Sum of all your samples that has been taken over the period you have configured divided by your configured average period. Here is something really interesting about this feature. So as soon as the PoE capable device is up, it starts taking the power samples for this buffer of 3600 seconds and it starts to fill up this buffer. Now by default, that display time of that power consumed average period is 10 minutes. So it starts taking these values and filling up the buffer, and whenever you try to display this, the last 600 seconds of average being calculated and will be displayed to your systems. Now think of a scenario where you shrink the average window from 600 seconds to some of the lower values. Here I've taken an example of 400 seconds. So I configured or reconfigured the average time period as 400 seconds. At that instant, the average window will shrink down to 400 seconds and the average will be recalculated for last 400 seconds. Now, there is another scenario where I reconfigured my power consumed average time period for 1200 second, which is like I'm expanding the power window or the time frame. In that case, when you expand this time limit which from 600 to 1200, instead of waiting for next 600 seconds of data, it will automatically calculate the value of last 1200 seconds of data and display the value. So here we come with the configuration of this feature. So first, the configuring of average time period, which is same as we have seen in the last feature. So you see the power consumption average period, which can be configured as the given value or between this interval only. Now, here are the show commands, which will help you to display these values finally to look your PoE power consumption. First is checking your average PoE power usage. So if you see the show, use the show environment power consumption and you seek for help, you will be listed with these three options, where you will see the third option as power over Ethernet or which is used for to show PoE power consumption. This is a new feature added in 10.14,000. Now this command will display the average PoE power consumed by standalone switch or all the VSF members listed in a brief view separately or the line cards in a chassis switch. Again, if you try to check further sub options for this feature, you will find the detail, the interface and the member. So the detail is about, it will show you the detailed view of your power consumption values. The interface is where you can filter out for which interface specifically you want to see this value. And for the member, which is in case of VSF stack, you can find out for each member that PoE power consumption value. So this command will list down the average values of instantaneous PoE power and average PoE power for each port of standalone switch, VSF stack, and chassis. So you are going to use show environment power consumption, power over Ethernet detail. Now there is another command that I was mentioning earlier in the top part of the slide, that show environment power consumption, power over Ethernet interface will list down the average values of instantaneous PoE power and average PoE power for a specified interface or multiple interface or the range of interfaces. Now, there's the command to check out the power consumption, PoE power consumption for each VSF member, which is show environment power consumption, power over Ethernet member, and then further you can mention the member name or the member number for which you want to get this value. Now, if the member doesn't exist in the stack, the output will be shown as not a valid member for the switch. So let's see the sum of the outputs related to this feature. So here I'm using a standalone switch and trying to see the output. So I use the show environment power consumption, power over Ethernet. As you can see, there is the number of the system, the description of the system itself, and the PoE average usage value. Further, we have a VSF stack where we are trying to check the power consumption value over power over Ethernet. So if you see here are two members in my VSF stack. For each one of those descriptions are written here. And for each member, it is telling me what is the average PoE usage. For the chassis, we have show power consumption, power over Ethernet, and chassis value is as mentioned here. Now I am using a detailed view of this command. So I have used show power or show environment, power over consumption, power over Ethernet detail. So the power consumption averaging period is written in all of the command outputs. So for this, I have a VSF stack where these two switches are in stack together. For each of them, average value of each member in VSF stack is shown. Now, further below, if you see there is a list of each interface. Here you will see the instantaneous value of each interface PoE power consumption, as well as you'll see the average value of PoE power consumption for each interface. Now, in that stack only, I have tried to filter out just to check the values of member 2. So I have typed the same command, just added the member 2 in the last of it. So now it is showing me the output for member 2 with the PoE total power consumption and for each port, the instantaneous and average power values. Further, you can check for the interface. So here I have checked for interface 1/1/3, for which it is showing me the outputs. Another thing is you can check for the range of interfaces. Once again, you can mix it up. You can check for a specific interface or for a range of interface as well. So for specific interface 1/1/3, this is the output. And for the range, these are the specific outputs. So this feature is also available by the REST API. For that, you have to open your Switch Web UI and click on 10.14 API. Further, you have to navigate to Subsystem and choose the second get option. After clicking try it out, you have to choose subsystem type as chassis. Under the subsystem name, you have to type your subsystem name as integer. So for instance, 1 in case of standalone switch, or the member number between 1 to 10 in case of VSF stack. Now, if you want to specifically see the PoE power consumed average, you have to choose this option from the attributes. After clicking execute, the average PoE power will be displayed for specified subsystem. Similarly, for interface, you have to navigate to PoE interface under the 10.14 API. You have to perform the get operation. You have to choose the interface name for specific interface you want to see the value. Select the PoE port power consumed average, and after execution, you will be able to see the average PoE value displayed for specified interface. Currently, average instantaneous PoE power details are not available under SNMP MIBs. Here are certain caveats about this feature. So in case of switch reboot, buffer will be cleared up and fresh samples will be taken. Which switch reboot will not affect the configured power consumption's average period, which means if you have configured a time period or average period as 600 seconds or probably 800 seconds, it will remain same after reboot. Currently, user does not have any capabilities to clear the buffer of those power samples that has been taken. So finally, let's dive into a quick demo and look at both of the features we have discussed in these slides. So let's check out the power consumption values first. So I'll go show environment power, and now you can see there are three options that we have. The first one is power consumption is what we need right now. So when I click show environment power consumption, it will list down the power usage and power output values for each of the switches in this stack, as well as the total power consumption of the whole system, which is the stack itself. Now I want to check the power consumption for just for member 2. So what I'll do, I'll type member 2. And now you see You can see the power consumption average for the second member only. Currently, the power consumption averaging period is set as 600 seconds. Now, let me show you by changing this power consumption period. So I'll go power, an average period, which you can set once again, let me show you, which you can set anywhere between 60 seconds to 3600 seconds. I'll go with 1200 seconds. I'll expand this window. The system has accepted. Now I'll go again and check the power consumption value. Now you can see the power consumption averaging period is changed to 1200 seconds, and the new averages and average values are being displayed here. Now you might not be able to see the change here because the power sample values has been same for the whole buffer probably, and that is why you are not able to see the change. But whenever there is a difference in the values, the new average will be calculated for the given time period. Let us move to another feature that we have, which we can again fetch using the same one. So if you check for the show environment power consumption and seek for the detail, you will find three options available, which is the detail, member, and the power over Ethernet. What we need to see is this power Ethernet option, which will help you to know the show PoE power consumption. So when you type this command and enter hit, you will be able to see the PoE average usage for each of your switches. Once again, it provides or helps you with further more details, which is the detail option itself, the interface option, and the member option. So when I check for detail, you see for the whole stack here, the each switch power consumption is mentioned. Here, for each switch PoE power consumption is mentioned. Further, for each port, you can see the PoE power drawn, the instantaneous values, and the average values is mentioned. Now let's check these details just for member 2. So if you see, here are the details of the PoE power consumption for member 2 as a system. And for each interface, you have the instantaneous power values and the average PoE power values being drawn. So like this, it is going to help you to know your power consumption or the PoE power consumption for each system or each interface or each subsystem. So this is a quick demo of this feature. Now it's time to look at certain additional resources. So we have the 80 plus certification that we discussed earlier, the details of which has been mentioned here. What is the criteria for each certification? How is it calculated? And what are the levels or the certifications are? Here is a list of HPE PSUs that you will be finding on the official website of 80 plus certification, where you can see the ratings for each of the power supplies. Here is a comprised or a brief view of those power supplies and what are the ratings for those. You can see most of the power supplies are rated for platinum or gold. Here are the list of internal PSUs that has been rated by 80 plus certification, which you can find here with their respective efficiencies. So thanks a lot everyone for watching this video and please stay tuned for upcoming updates.